where everyone faces forward and listens to two fascinating talks, as we're going to do tonight. The other style of event is a project night, which is very informal. We get round tables or something, and people come with their laptops, and they talk, or they work, or they teach, or they learn, or they mingle, or whatever you want to do when you get into a room with 100 like-minded Python users. And we alternate presentation nights and project nights, and so there's one of each of those every month, except we're not doing presentation nights. If you've never been here before, we're very glad to have you. We try to welcome skill levels on the entire spectrum, from how do you spell Python to I wrote Python. So whatever you're into, we're trying to accommodate you. If you have ideas of stuff that we can do better to make all of that possible, please let us know.
A couple of logistical things. So the pizza out there is for you. We'll explain what it came from momentarily. The drinks in the fridges are also for us, courtesy of Microsoft in England. Thank you. Bathrooms are all the way down that way on the right. And the Wi-Fi has been showing by here, but it's BP1120. That is Boston Python and Z.
Right. How close are we to the You close?
Rebooted.
No.
So I need Wi-Fi, and then we can get rolling.
Cambridge.
The largest annual Python conference, PyCon, in North America, is happening in Montreal in April of 2014. Montreal is an easy car ride, bus ride, or 45-minute plane ride from here. And PyCon is a really fun way to level up your Python, meet more Pythonistas, get a job, bring your kids. It's a really fun, volunteer, organized conference. I will be there, Ned will be there, lots of people will be there. Early bird tickets are currently on sale for PyCon. There's a fixed number of early bird tickets, so if you would like to go to PyCon, now is the time to buy the tickets on the cheap. There are student discount rates, all kinds of good stuff. There are tutorials. It's just a really good time. So if you're interested in going to a Python conference, PyCon is the one to go to, and it's in Montreal. Couldn't get any more convenient.
And even if it sounds like it's not for you for whatever reason, keep in mind that all of the Boston area presenters who are going to PyCon do rehearsals here as presentation nights in March. So you'll get to be able to come here and get a preview of what they're going to talk about and help them improve their talks before they get to the big conference. Cool.
I think that's all the announcements, so we're going to get started in just a second.
Right, we've got some logistical issues to set up there. The pizza tonight, we're in an interesting position tonight because our speaker is also our sponsor. So the pizza tonight was bought by Continuum Analytics, and Ian is going to be talking at some length about what Continuum Analytics does, but I would just like to thank them up front for the pizza. When we're done here at about 9 o'clock, before we get started, how are metaclass is different in Pi 3 than in Pi 2?
Okay, I think I'm ready to start. Ooh, and I'm right down.
Good, because I don't know.
Okay, so if anyone wants to follow along, and I don't know if there's a way for me to turn this down. It sounds pretty loud.
No, it's good.
It's good? It's not too loud? Okay, that's maybe a little bit more manageable, at least for me. j.mp/bostonpython-continuum. This has the kind of a landing page for material for the course here. Usually it's something for people teaching courses. Right now it's going to be about a 30-minute talk with time for some questions. So that URL will take you to this content here, and there you've got a bunch of links to basically the key things that I'm going to be talking about here, including links to the slides that I'm presenting. So the intro slides and then the Blaze slides. I'm doing a bit of a demo in between. So I'm going to jump right into slides and then the talk part, and then do sort of an introduction afterwards, a little bit out of order, but let me bring up my presentation. Oh, let's turn off the mirror quickly. This is where it got confused before. Okay, so I'm from Continuum Analytics. I've been with Continuum for almost a year now. Prior to that, I spent 5 years as a postdoc and researcher, computational scientist at Harvard and Harvard Medical School. I see some of my Harvard colleagues out there. Hi, guys. My background's in computational science, electrical engineering originally, and then a PhD in computational particle physics, working on the CERN experiments. But at Continuum, what we are motivated by is making data analytics possible. It's really our driving motivation. We take 10 minutes to throw up some slides here to paint you like a kind of big picture vision of what we as a company are trying to achieve, maybe a little bit less than that, so that we can then get on to talking about how we're actually doing it, talk about some tools that you guys can use. So really, our big picture vision is to make data analytics awesome. So before I start flipping slides, I want to ask how many people here have heard of IPython notebook before? I want to know what my audience looks like. Excellent, okay. How many people here have used NumPy before? No NumPy and used NumPy before? A lot of people, excellent. And how many people have heard of Continuum Analytics before? A fair number, okay. So Continuum's a relatively new startup, about 30, 35 people who are part of the team. And again, I'll say a little bit more about that later. It's a relatively new startup, people who really love data analytics, computational science, and we believe that Python's the unifying language right now in our present day to be able to do that really, really well. So what we want to do is provide liberation from Excel in the 1990s. A lot of people are still stuck in a world of Excel-oriented analytics, data analytics, horrible graphs that look like this, and models of doing analytics, even if they've escaped from Excel, they're still stuck in the 1990s. They're still using tools that were developed in the 1960s or 1970s, commercialized in the 1980s, and that they learned maybe as an undergrad or as grad student in the 1990s. Well, we're decades past that point, and so what we want to do is provide 21st century performance analytics, the kind of stuff that makes you guys show up here tonight on a weekday night and try and find out what are some ways you can leverage Python to do some cool and exciting things. So tonight I'm going to give this very brief, high-level picture of things that we want to do. We want to make analytics easy. We want to make sure that the analytics that people are able to do has high impact. And then we want to make sure that it's performant, that it's able to fly, able to scale, able to go fast, able to go parallel, able to go big. And so these are some of the key drivers of the things that we're doing at Continuum. First of all, make it easy. We have this idea that everyone everywhere should be able to show and tell their data analytics story. So what does that mean? We've got this idea of, that some of you might have heard of before, it's kind of gaining in popularity, these ideas of reproducible science and data journalism and data-oriented information and decision making. And that these analytics stories need to go beyond just PDFs and PowerPoint slides. That's why I'm trying to do my part of the PowerPoint slides to a minimum and try and show stuff off and then answer questions. I'm actually trying to aim for this to be not too long in terms of the content that I'm putting in front of you, more of an opportunity to show off a few, kind of survey a few pieces of what we're doing. So we have this idea, everyone everywhere, not just experts, not just people who have degrees in statistics or people who have PhDs in computer science, or having this idea of you've got people in marketing and you've got people who are in analytics and you've got people who develop like dashboard applications, things like that. We want to kind of enable people across the board. Why do people use Excel right now? Because they know how to use Excel. Why is Tableau being so successful? Because Tableau looks a whole awful lot like Excel. And so you're able to transition easily from people who have numbers, who want to generate pictures, who want to make decisions, who then want to be able to communicate those things. Again, we want to be able to take sort of a step beyond that for this idea of show and tell data analytics stories. So on this show and tell side, for making things easy, Continuum has 3 key platforms and tools. So the first is Anaconda. Has anyone here heard of Anaconda before? Using Anaconda? Who's using Anaconda? A smaller number of people. All right, brief story about Anaconda. So Anaconda is a freely available Python distribution. It includes about 100 packages, packages and tools in addition the Python standard library, and critically it includes a lot of the ones that require compilation on your platform. If you try downloading them and installing them on your own, if you don't have a compiler, you're probably going to run into troubles, and some of them just are, even with compilers and experienced compiling software, you can run into all sorts of challenges. Anaconda is about a 200 meg download, gives you core Python standard library, plus it gives you, again, these 100 or so additional packages compiled for your platform, Linux, Mac, Windows. So Anaconda is our software package for giving you a foundation on which you can start doing your Python-centric data analytics. And I'm going to say Python-centric a number of times. When I say Python-centric, what I mean by that is that we at Continuum really think Python's the bee's knees. We think it's the best language available today for doing general purpose data analytics and for doing kind of broad spectrum development work, where you can kind of hit a whole bunch of different requirements from sort of the UI end and the performance backend pieces, the algorithmic pieces, the server interaction, database interaction, file system interaction. Now, that said, even within Continuum, you write C code, you write JavaScript, so we do work in other languages as well. But Anaconda gives you a really solid foundation. It includes things like Spider, which is a powerful IDE. If you're used to using things like RStudio or using MATLAB, Spider gives you a space that looks like that. Includes pip as well, and includes all of these other tools. On the other end of the spectrum, so on the right hand of that slide, we've got Wakari. Wakari is a web-based service, freely available. You can go to wakari.io right now, and we'll look at that a little bit later, what Wakari provides. And Wakari is a web-based platform for doing data analytics. So you can then, in the same way you can go to Google Docs, and you can use Google Docs, you can go to wakari.io, and Wakari gives you a Bash shell, a Python shell, and it gives you an IPython notebook, and it gives you storage space for your files, and the ability to spin up parallel nodes. That's paid feature, but there is a free base that you can make use of. And it has the full Anaconda Python distribution available to it. And the piece in between, Conda is a packaging system that's been developed by Continuum. Again, it's open source, freely available. And the Anaconda packaging environment, you might look at that when we're here in the Python community, and people say, well, why are you trying to create yet another easy install pip Conda? How does this fit in? The point is that Conda actually is meant to work really well with Python packages, is actually language neutral. And so I'll talk a little bit later about Binstar in a few slides actually. And when we're in the analytics world, and I realize this is a Python user meetup, but a lot of people are using Python because it's this brilliant glue language where you're trying to bring together lots of different pieces. Our operational reality is that we've got packages that aren't necessarily in Python. They're C code or JavaScript, Fortran or whatever, Java, these kinds of things. And we need to be able to package and distribute these things as regular users, non-root users, not as RPMs, not using YUM. We need to be able to do this on our Windows machine and our Mac machines, and not having to switch between Homebrew on my Mac and YUM on a different machine, and then a MSI installer on a Windows machine for these different packages. So Conda attempts to address that issue for, we believe, people like a lot of you, for people who are in the world of multiple packages in different environments. So Conda is this piece that lets us do that. Wakari makes use of Conda, and it gives you a virtual end. So Conda kind of combines two ideas, both pip and virtual end. It gives you a package manager, which is a language agnostic package manager, although it's made to work very well with Python, we'll say, as well as an ability to create virtual end-like virtual environments that use linking instead of independent installations. So the Conda actually has a mechanism for like locally caching packages and being able to look at different package sources easily, called channels, and these kinds of things. And it makes it really easy to set up and clone environments in a way that we believe works a lot better than just using virtual end. And additionally, it goes beyond just the concept of Python. So Conda is used both in Wakari, our web-based service, and in Anaconda. or like local install, where you install on a server or on your own machine. So again, these platforms and tools are foundational, we believe, to making it easy for people to access the analytics tools and the techniques that people are desperate for, which I believe is part of why we have the folder here. And I don't credit myself or Continuum with the number of people who show up. These events are always oversubscribed because people are desperate to figure out how to do a better job. They love Python, they want to do a good job with it. But the reality is that there can be some hurdles and some challenges. And again, all of this is to build up this idea of Python-centric analytics. So this is kind of the first point, make it easy. Second of all, we want to be able to have impact. And for this, I'm not going to elaborate a lot on it right now, but the core concept are these four ideas. We've got a narrative that we want to communicate. We've got data that's sitting behind that narrative. We try and use graphics because graphics are a powerful way of communicating data-oriented stories. And then we've got code, which is related to our particular analytics. It's actually going to be driving the generation of graphics, the generation of derived data. And so these four pieces come together. And the slide on the left side, the image there is showing a snapshot of an IPython notebook. You're not supposed to be able to read it, but it looks like a lot of you have looked at IPython notebooks before. And so you can see we have this combination of a narrative with some text, followed by some code, and in line with the code, there's some access to some data sources that are there. And then following that, we've got some graphics, which are some the representation of the output of that code. So through Wakari, we're allowing people to build those narratives, build those stories, and then be able to communicate and publish those stories using techniques, which again I'm going to demonstrate in a little bit, which go beyond just a static IPython notebook file, which you can then publish as a gist on GitHub and look at an MD viewer. That doesn't connect you to the original data sources, or if there are additional modules that are associated with it, these kinds of things. So with Wakari, and we're working on building that also in Conda, to have the ability to publish these data-oriented stories that encapsulate all of these elements. They encapsulate code that goes beyond just code that's in the notebook, data, graphics potentially, which go beyond just static graphics to part of what I'm going to talk about later with Bokeh for interactive graphics. And it gives you that whole package. And this then is part of what gives us reproducible analytics. And again, I'll come back to that a little bit later. So, in terms of having an ability to have impact, some of the key pieces here, Binstar, IPython, and Bokeh. So the first thing I'll mention is right in the middle, IPython. There's a little star there, you can't see on the bottom here unless you're in the front row. So we're close friends with the core developers in IPython. No one at Continuum is a core developer in IPython. IPython is not a Continuum product or project. So the things that I'm talking about, we use and we leverage IPython heavily. We've got our own patch version that we incorporate into Wakari to make it multi-user and have it support effectively switching of virtual ends inside the IPython notebook. So we know IPython very well, we know IPython notebook very well, we know the IPython notebook team very well, and we think they're great guys. They're not part of Continuum, so I'm not trying to steal their thunder. They're doing incredible things. Some of you might have seen that they were just announced last week or the week before that they got almost $40 million in a 3-university consortium to do a 5-year project to do some really fascinating stuff in enabling cross-discipline, reproducible computational science work to encourage reproducible science and these sort of data-oriented stories. And that was largely led by the IPython team. So kudos to them, and we rely on them a lot, we work with them a lot. The other two pieces, Binstar and Bokeh, are projects which come out of Continuum. Binstar is a free online service which provides something like the cheese shop, python.org, but it lets you have personal channels. So you can publish your own personal packages and version them and update them, and then you and your friends and your project team members can then subscribe to those channels. And if you're prepared to pay us, then you can have private channels for private projects. It's very much like a GitHub kind of model, but rather than it being at the code level, it's at the package level. And so it gives you this ability to then package things that are then pip installable or conda installable, which if you're using pip, of course, that can be Python packages, and if you're using conda, they can be any arbitrary packages. So BinStar is this piece that allows people to produce their own code and then publish packages, which can then be used by people who aren't software developers, by people who want to be users of these end products. They want to be able to load up an IPython notebook, and they want to be able to like interact with a particular analysis. They know enough Python to be able to make bits and pieces, and as Python interactivity tools develop and improve, there'll be more and more widgets built into IPython notebooks, and what you'll see is the code pieces will become more and more behind the scenes. And so we see BinStar as a key piece of it, a key enabler in that domain for people to be able to publish and share their own work, not necessarily publishing it to the Python package index. And on the bottom, Bokeh. So Bokeh is a project, it's an open source project. You can go bokeh.pydata.org and you can then click through the GitHub link. Totally open source. The 0.3 release just came out last week, I believe. And that's a project which is led by Continuum, and it's aiming to provide web-based interactive graphics generated entirely from Python. So you can write Python code, and Python code that you write, instead of generating a static matplotlib graphic, is going to go and generate for you some interactive JavaScript that you're then able to embed in a web page or embed in a Python notebook, and that people can then talk to or interact with. And so Bokeh's got a big vision. It's on the path to producing things that can achieve that big vision. We'll look at a few of the features that are there. And again, to let it to kind of drive the point home, reproducible analytics is really what we're pushing for. You've got a story, you've got code that's going to help you build that data-oriented story, you've got graphics which are part of supporting it, and then there's kind of data that sits behind the whole set. And so we really have this, again, this key idea of reproducible analytics. And finally, only a couple slides left here, is the let it fly part. We want to be able to produce things, which means that it doesn't take somebody with deep systems knowledge to be able to parallelize or scale their code, to require what really takes weeks of learning to be able to set up a Hadoop cluster or be able to set up a computational cluster, even with AWS machines. Star Cluster, of course, makes this easier for you, but there's still all sorts of challenges and gotchas. So we're looking at trying to find ways both at the programming level and the systems level to enable people to scale the computations and scale the strategies that they're using for their analytics and for the code that they're developing. So any analytics strategy today must scale. You can't just have something that runs in your own laptop or runs on the 4 or 8 cores in your laptop or 16 cores, 32 cores on your desktop. It's something that will scale across a server farm if it needs to be. And so on this front, Continuum's got a number of scaling libraries. And the scaling the libraries that are there to facilitate scaling are, I'll describe them briefly from left to right. IOPro, so IOPro helps map things like databases, and we have interfaces to ODBC drivers and to Mongo databases, things that will read in data from very large flat files, and bring them into NumPy arrays very quickly and efficiently. So IOPro is a one scaling library that does that. That's a commercial product. So most of what I'm talking about here is freely available and open source. I've starred things which aren't, just to try and kind of separate the message a little bit. But IOPro, for a lot of our enterprise customers, that's a really powerful tool, because otherwise there can be bottlenecks getting, a lot of people want to talk NumPy to their data. If their data is really big or is held in the database or in big CSV files or flat files, text files, these kinds of things, it can be hard doing that. and the NumPy's native mechanisms for reading things in can actually be quite slow. It goes through a few steps, builds Python data structures first, and then from Python data structures builds NumPy ND arrays. And that can take more memory than you've got on your computer, basically. It's like the big challenge there. NumPy provides a just-in-time compiler that leverages LLVM to produce C code that's on the fly, C compiled code that's interfaced into the Python interpreter. So NumPy is an open source project, freely available, and has decorators that let you that will inspect your code and then try and do effectively like siphonize code fragments that are sort of appropriately constructed. But other than putting a decorator on it, you don't have to do a lot of the kind of things you need to do in Python. It is just pure Python code. And so NumPy provides some incredible performance speedups under a lot of not just made up use cases, but under real use cases. NumPy Pro, exactly the same idea, but to CUDA, and that's a commercial product. So our NumPy Pro is a commercial version of NumPy that will give you CUDA compilation. And finally, Blaze. Blaze provides, is a next generation NumPy, which provides a basically a more modern perspective on the data structures that NumPy can use for data representation and for out-of-memory data structures and for oddly shaped data structures and sort of arbitrary data structures. So NumPy, for people who, sort of a very brief review for those who know about NumPy and those who don't, effectively there are two kinds of ND arrays. You can have a regular ND array, which is a single data type associated with it. So everything in your ND array is a float or is an integer or is a fixed size string. Or you can have what's called a record array. And record arrays then have sort of named fields, but the data structure for each field is fixed in terms of its structure. That and lets you mix floats and ints and strings and things like that. Blaze lets you have more arbitrary mixtures of data structures. You can have like objects in your Blaze style ND arrays. And so these three libraries allow you to access larger sets of data, have more performant access and structures, and do things like out-of-memory access to data. So you can actually have data that's mapped to files or read from databases, and that they're basically adapters that will pull in data from multiple sources in parallel. And additionally, with very large data sets, one of the objectives of Blaze is to be able to take the computations and map the computations to wherever the data sits. So you have sort of the concept of a computational kernel that's pushed over the data rather than trying to read all the data into a single processor. And I saved that before I finished my last slides before I finished my last PDF slides. I think my ones online actually have the public file. I think my ones online actually have a proper final slide. Let me go and grab those from slides, Blaze slides. Okay, I want to cut into our follow-up time for some of the other speakers. So I'm now going to take let me just see if I can, I'm not lying to you, and in fact, there we go. Here are my last slide. Those are my last two slides are supposed to look like. So the SlideShare version is actually more complete than what I have on disk because I had to do a hard reboot there. There we go. So really what we're trying to push towards at Continuum is a Python-centric analytics nirvana. So we have within our team people who've worked in all sorts of different domains, pharmaceuticals, people who worked in computational science, people who worked in energy, oil and gas, people who worked in finance, medical imaging, and we've also done a lot of consulting across the team of 30 or so of us. And we feel like we see what the issues are, and there are a lot of common issues. And we're trying to address a whole lot of those at once. We're trying to leverage the open source community. A lot of the people within Continuum have developed core scientific computing libraries within Python. Our CEO is Travis Oliphant, who's sort of the most recent holder of the torch for NumPy, and has spent the last decade developing and extending NumPy off of numerics. We've got people who developed PyTables and NumExpert, who are part of the company. And we're trying to attack these problems from many different perspectives. So that's my last slide. That's what you'll get from the link for the presentation for the company. Now, let me take a moment to show you some of the features of what we have in Wakari. Hopefully my network connection sticks with me here. So you go to wakari.io. I had a saved cookie, it looks like, so it logged me in directly. This probably does as well. I can log out from this session. Really easy to get into Wakari. Username, email address, and password, and you'll be in. Once you get into Wakari, our core model for interacting with Wakari is I might just die. I'll just talk loudly if I have to. Okay? Yeah. There we go. I've got a battery light on here. Okay. I'll just speak loudly then. So our core view in Wakari, and let me bump my font size up here so you guys can see a little bit better. Some of the show might go off a bit, so you might have to jump back and forth. Is a file viewer on the left-hand side, and on the right-hand side, sort of tab-based viewer, where we've got the option to bring up terminals. So I've got here a regular bash terminal. I can access all of these files here and do normal sorts of things, the bash prompt. Additionally, we've got an IPython prompt. You probably can't see that there, but we can do things like regular Python code in an IPython terminal. And additionally, this piece that I was mentioning about Conda is that we've got, these are like virtual envs. So we can switch between different virtual envs, and a different virtual envs can contain different Python versions. So this is something that virtual env doesn't support, effectively doesn't support. Conda allows you to have multiple Python versions, so you can switch your code pretty easily. You can have different spaces that you're working in, and so these are kind of the Wakari standard ones. And then down here are some specific ones that I've created in my own account. Additionally, we can go into our notebooks. And here I've got the notebook that I prepared for this talk today. So for people who haven't seen IPython notebooks before, this is just pre the 1.0 release of IPython from July or early August. We have a new version of Wakari which is being released hopefully in the next couple weeks, which updates to having IPython 1.0 available. But of course, we can do the same kinds of things in here that we do in our Python, regular Python terminals. And so we can put code in here, and we can change these cells to have some markdown. We can say, and the markdown then gets rendered in those cells. So pretty easy interface for using it. And additionally, we've got this publication functionality. So here, if I click on this share button, here I'll need to rescale this so I can see the output. We've got this share functionality here, which allows us to then package together a particular notebook, share the contents, and it takes about 10 seconds or so to share it. And then here we've got a static view, and you could just put this in an email or put this through a URL shortener if you want a shorter version. And go ahead and share that with people. You can see this is added in here, those extra examples that I put in. And so this can be updated and republished. So it says share. In fact, what it's doing is a snapshot. So it's snapshotting it and putting a snapshot in a publicly accessible location. So it doesn't track. Clicking share doesn't start tracking my content here live. The sharing mechanism in Wakari also allows you to publish at the directory level. And so when you share at the directory level, you publish everything inside that directory, and you're then able to select notebooks and have sort of a whole catalog of notebooks. This is a really effective way for teaching kind of larger courses or putting together a whole big set of content, which includes, again, I mentioned this at the start, data files and .py files, some images perhaps, and a collection of notebooks can all be published as sort of as a single catalog. And then users here, if they like, they can click run or edit this notebook, which will then copy that snapshot into their own Wakari space, or they can bump the font size up there, or they can download the notebook and use it in their own local IPython notebook server. Or if it's a bundle, they can download the entire bundle and they'll get a zip file with the whole thing in one place. So that is a quick look at Wakari and some of the key features. Some of the key features in Wakari: terminals, IPython notebooks, files, bundle sharing, and publishing. Okay. Carrying on, I mentioned a few other pieces here, and I'm going to give just a tour of these before I show a few slides on Blaze and give a few of you some previews on Blaze and what Blaze is doing. So Bokeh aims to provide a D3 style interactive graphics. So we can go and look at some graphics like this. Graphic of the state of Texas. And this isn't just a static graphic. We're able to pan it. We're able to zoom in. There aren't other data points in here that we can see, but I'll show a few other examples where there's data selection capabilities as well. So this is available just as an example served from the web content here. These same kind of content can be embedded in an IPython notebook. It's not relying on a server running on the back end. It's just pure JavaScript that's been generated by Bokeh. The other example I wanted to show off here was this example, where we can zoom in on some of the data, zoom on some of the results. Now, for a more interesting example here, this one doesn't have as much text around it, isn't quite as interesting, but let me scroll down to our data here. So this is a plot of two scatter graphs which are showing, let me just bring up the scatter graphs here. They're not labeled, unfortunately. The y-axis on this graph is the year, and the x-axis is miles per gallon. And these are cars with their miles per gallon by the year they were produced. And the graph on the left is the weight of the car and the miles per gallon for the vehicle. And here, if I use the select option, and I select a bunch of data points on the left, those same data points are being highlighted on the right from the selection. Now, excuse me. We additionally have tables here that'll be produced because of the way this is being generated at the moment through the Wakari's bundle sharing, and this coming from I think 0.1 version of Bokeh that generated this. Unfortunately, at this point here, these tables were generated, but the automatic table filtering isn't working in this version. But in our more recent versions of Bokeh, as you select data points, then your data table selections here are updated as well. So you get data tables that are then associated as well. So Bokeh does more than just, let me go back to show the code example here again. So the code examples, this is like all of the code that exists here. It's very, very, very compact. WebPlot is the Bokeh module that provides the plotting. This is pulling in a data set called cars and setting up notebook sources and setting up a notebook connection. And then here we're reading in from Pandas data frame. We read in autompg.csv, so we read the data in using Pandas from a CSV file. And we then produce these WebPlot scatter graphs, which are using Bokeh in the back end, simply specifying scatter, MPG versus weight. MPGs, again, our x-axis, weights our y-axis, for our plot 1. And then our plot for figure 2 is MPG versus year, and we specify our source for our plot is coming from this Pandas data frame. And then we grid the data, we grid those two plots, and we get our output here. So that's a brief look at Bokeh. Let me just go back and remind myself if there were any other examples. So here on the Bokeh site, again, you see the usual GitHub banner on the side there, open source and available on GitHub. And all of these examples here have code that goes along with them. So here, this is a more sophisticated plot where you can see there's more work being done to produce these multi-layered plots. But again, the plots that we have here should be able to click zoom. And we get zoom in on these data. And across the data sources. All right. So in the interest of time, carry on, show off briefly Binstar. Binstar, package management, free public package hosting. So you can publish packages here in a way, again, which is very similar to Python package index, the cheese shop, or you can also set up personal channels, which are effectively like namespaced under your name and then under project names. And then the packages can be versioned as you update and add them in. Let me get my. Is that rebooted? Okay. So for me, here's my Binstar login. I only have one package in here, which is a Node.js package that I created last week. So I only have one piece of information in my history. So that's just. But then I'm also part of this organization, Wakari. The organization Wakari is we publish our packages for the Wakari project to Binstar, to a private channel on Binstar. And so here we've got a whole bunch of the. Let me try and find a good example one. Here's a particular package, S3 command, and then here we can see that we only have one release of this. But so the versions are, again, within the context of a particular package. So it's a nice namespace mechanism for publishing and sharing content using this channel strategy. Okay. I do not want to eat into the next speaker's time anymore, so I am going to fly over to my Blaze slides and go through these really, really quickly. So, Blaze, next generation NumPy. Blaze is very much a work in progress. So Blaze, well, there's a version of Blaze you can download and run. There are examples that you can look at. It's really at the development stage now. So as a result, I'm going to go through this. There's a bunch of slides in here for people who are interested. You can get them from the URL that I shared. But I'm going to move through here pretty quickly. Blaze.pydata.org. Comes from a combination of NumPy and PyTables, out-of-core distributed and optimized NumPy. NumPy arrays have a header, and they then have the individual data fields that are a particular size, and they're then efficiently mapped to memory so they can be accessed, and you can write C libraries that'll interface with them very efficiently. Blaze aims to have different kinds of arrays, both ND tables, which look like PyTables sort of things, and ND arrays, which look more like the NumPy side. Now, the important part here is the bottom row, which is this idea of there being deferred content. Deferred content can be read only when it's requested. So you get a late binding of reading of data from databases or from a URL or from some data source that perhaps is providing live, like iterable style data feeds. So you can have deferred content. So you've got a concept of this is where my data sources come from, but I don't actually fetch those data sources until there's a request for them. So the deferred handling allows access to very large arrays. So the chunks can stream through memory rather than all the data being held in memory at once. And again, multiple sources can comprise an array. So an array could be pulling content. You can imagine the concept of like a synthetic record array, where contents in a record array are being brought together. They're defined at sort of a virtual level. And when you request a piece of content, you get a record array, which would pull in content from memory, from some files, from a database, from a CSV. So and possibly from different server sources, different disks, different machines. So you can have memory-like things, so these look like NumPy arrays, file-like, so you can do random access random chunks, and because that data could potentially be sitting on some central source, you can do parallel access to it because you know the data is on a disk, and you can then optimize the way different processes access that data, or stream-like data, so you can deal with sequential seeks to read things from, say, a network socket. Those are the three things I was just mentioning. So these indexing mechanisms allow for many, many different orderings for how you pull the data in and read over the data, and a more sophisticated data shape type system. So the content is more sophisticated than simply record arrays of a fixed kind of struct, effectively, or a single ND type. And this allows for all sorts of interesting containers, with slides describing some of the features of those. So this concept of Blaze agents allows you to basically produce the equivalent of like a computational kernel, and then you can push that computational kernel to process the distributed data sources. And so those can execute on distributed data with distributed computation and then be pulled back in. So this is one of the pieces that Blaze is looking to aim. So this slide was from a talk about 6 months ago. This cartoon was put in a Blaze slide about 6 months, maybe almost a year ago, which was how. And the middle part there, for those who can't read it, in this complicated equation, and the solution is then a miracle occurs. And the comment from the senior academic is, I think you should be more explicit here in step 2. So Blaze is real code that exists and runs right now. We've got benchmarks on real problems. And we can see here, these are both logarithmic scale. We can see that for very small things and very small, what's the scale in which NumPy in memory is faster? Well, actually, up to about 10 million elements. So 10 million elements might sound really big, but in fact, you can have ND arrays with 10 million elements pretty quickly, pretty easily. So Blaze right now performs better when you start talking about quantities of data greater than 10 million total elements. So that's kind of the scale at which Blaze currently performs. And of course, some of these features that I've been describing, you just simply can't do with ND arrays and NumPy. So this is sort of where Blaze is heading. A number of those slides I've talked about are aspirational, but there is real code there that will do a number of these features for sort of disk-backed data for out-of-memory data analysis. The last slide I've got in here is to say that Continuum's a big supporter and one of the founding members of the NumFocus organization, which is a foundation for open code for usable science. And it's more than just a Python oriented group, but they do a lot of great work to promote reproducible science, computational techniques, and to encourage the development of data analysts like ourselves. So they sponsor the PyData series of conferences, and we're very involved in helping to make those things happen. And so NumFocus is a great group that we're a big supporter of, and we want to sort of spread the word that they're out there, and if you hear of them, pay attention. That is the end of my talk. The last thing I'm going to say is that I will be going for drinks afterwards, and look forward to speaking to anybody who has more questions than we might have time for now. I don't
Let's
know.
do 5 minutes of questions.
5 minutes of questions. I've got a stack of laptop stickers, Anaconda, Wakari, Continuum, and NumFocus, I think, 4 different ones. If you come and talk to me, you can have 1 or 2 until I run out. Thank you very much, everyone, for having me. I'm sorry I was a little late getting started. Got a lot of interesting stuff here, and I'd love to hear your thoughts and questions about what we're doing and about how it can help you. Thank you very much. Questions? Yes.
So, Bokeh looks like it would be really awesome to use for a group until you get to the part where you want to show it to the rest of the world. If you don't want to show it to them on the computer, is there stuff in the works now, or that you didn't get to, for if you wanted to turn some of that data into like a poster, or put it on slides, or print it out for an academic paper?
So the content. So this is always one of those challenging transition points between the interactive data that you get with really nice interactive like landslide or reveal JS presentations, and then having like a PDF that you can print out to give people because you're running a course. So if you're able to produce a PDF, then you get PDFs from the content that's generated. Bokeh will produce kind of your static view that's generated in your web page. Your web browser will do a pretty good job of rendering that into a PDF. So you can grab it that way. We don't currently have serialization techniques to sort of snapshot the content, but we want to be able to do it. We want to be able to kind of have it both ways, really, to be able to generate high quality static images for publications and for posters and for PDFs. Yeah?
So in regular NumPy, when you load something that's larger than memory, with the memory map, you can have some out-of-memory information.
Yes.
Is Blaze still faster than that?
Blaze aims to be faster than that, so that you can actually not just, so you can actually spread your data across disks, so you can like leverage your storage infrastructure, and your disks can be where your data is held. And so that happens without you having to worry about the memory mapping. So Blaze, again, you saw some of the numbers there. At very large sizes, it'll do it well. But memory mapping in NumPy works really well. So if you can leverage NumPy for your particular application, and that's sufficient for you, then you should keep using that. Yeah, over there.
Are there any efforts on the Bokeh side to say network or graph visualization? I've explored the 3.js and
Yeah.
some basic things that you can play with a little hard.
Yeah. So we want to be able to do network graph rendering, and the primitives are all there to do it. But we don't want you to be stuck with the level of primitives that you're stuck with in D3. We want to give you higher level constructs that will generate graphs from like dot files, for instance, and things like that. We don't have that functionality in there right now. That's definitely where we want to get to, so that it's more than just bar plots and pie charts and graphs and scatter plots and things like that. We want to be able to do more dynamic, interactive, drill down into data points, these kinds of things. So it's on the roadmap. It's not there right now. Yeah?
But from your approach is not to generate JavaScript data. It's more like you have a JavaScript library which
we leverage. So we produce data which then the Bokeh JS JavaScript library can then leverage. Yeah.
Right. So it's not using it.
Right.
As a substrate.
Yeah.
Okay.
One or two more questions? We'll call it a day. I will hang around afterwards, and then I will be going for a beer with kind of the crowd that goes for beer. So once again,
thank you everyone very much. And please be in touch if you have any questions. If not tonight, look me up on Twitter or email me. Thank you.
Thank you, Ian, both for the talk and all the tools and the details. We're going to take a 5-minute break while we switch. Okay, so you can get up, you can get drinks, then make sure to don't take longer than 5 minutes. We're going to get started.
Just
John, nothing else is clear, it's clear that Scout employees know how to attend events where their company is buying the beer. Are we ready to go, or?
I can get started while she tinkers.
Well, I'm going to introduce you. So, John has been a quiet force amongst our midst, and I think is a great demonstration
Cool.
of Project Nights, because some of what he's going to tell you happened at Project Nights. And I have to tell you, ever since I've heard about this talk, all I can think of is that John is like our very own Clark Kent. He is a mild-mannered journalist who, under the cover of darkness, is out fighting the bad guys with Python. Whatever. And just to give you a sense of his wide range of talents, and also the interesting life that a Boston Python organizer leads, one of the logistical details we had to work out before John could commit to doing his talk tonight, is that yesterday he was in New York City doing a dance based on dog-human coevolution for Purina. That might be a topic for Meat Hall. I don't know. Honestly, I don't even know what that means. But the dance, I guess, went okay. John is here. The dance went okay?
Went great.
Okay. John is here tonight to tell us about the bad guys. Go, John.
All right. Hello, everyone. We're going to be looking at some code tonight, and the font is quite small, so we have a crack team on it. In the meantime, Sublime Text, not so
I
good.
did a Python dictionary to change your font size, and it's not working.
This is a UI fail.
Who knows why this is happening?
If anyone is a Sublime Text expert who knows how to deal with the font,
Nothing obvious words.
Command Plus isn't working
No,
for some
that does
reason.
not work right
It's
now,
weird.
so.
Anyway, raise your hand if you are if you consider yourself to be a newcomer to computer coding, kind of a relative newbie, sort of, you've done a bit of computer programming, but you haven't done a degree. You've written very little code yourself. Raise your hand again. Okay, everyone else can leave because this talk is for you. But I hope the rest of you will be amused at least. Maybe you'll recognize some of your earlier self in my experiences. So I knew almost no computer coding a year ago, and it was actually this group that really I didn't get a lot of specific help on specific problems. I kind of, for whatever obsessive reason, had to do them myself. But when I would run into general problems, like for example, I would hit my head against the same wall 10 times, I could come into project night and at least solve the general problem and discover how much trouble I had created for myself unnecessarily. That's the typical story. So I am also a scientist. I'm in the same department as Ian was at Harvard, doing data-driven journalism. So I'm the only, as far as I know, the only journalist in residence in the School of Engineering and Applied Sciences. And my PhD was in molecular biology, not data intensive at all. It's like squirting liquids into other liquids. And I've been doing it ever since. And so my sort of coding journey began actually a few years ago when I was embedded in Kandahar in Afghanistan. So completely traditional journalism type activity. And the story I ended up pursuing was a data story. It was a secret, until then, secret database of civilian casualties that were being created as a result of the war. The official storyline was that they weren't keeping track. Some of you may remember "We don't do body counts." It's a famous quote from Tommy Franks. But they were doing body counts. And I discovered that not only were they doing it, but they were doing a really good job. And all that data was just sitting on servers doing, nothing, basically. They were using that data to try, the military, ISAF, which is essentially NATO's presence in Afghanistan, was using that data to try and take a data-driven approach to their policies. So, for example, they wanted to reduce casualties at checkpoints on roads. So, essentially, they went to their in-house wonks and said, fix this. We've got tons of operational data. tell us essentially if you see any pattern. Is there any way, what tweak works? And we're willing to do experiments and take risks. And they tried a bunch of things, and they took a data-driven approach, and they brought down casualties dramatically. And so that was one of the claims that was made to me in Afghanistan by the brass. And I said, I would love to see that data, because this is a story worth telling. And frankly, if you've got classified data that I can't even see, then I can't tell that story. All I'm going to be doing is saying, you claim that there is data supporting this. And they were very uncomfortable with that. But then, so luckily, and this was a real journey to discover for me, the military is made up of, it turns out, people with a pretty normal distribution of niceness. You get all kinds, and you just have to find that outlier, someone who is going to guide you through the labyrinth, and I found that person. And they said, if we just stop calling you a journalist, you have a PhD, let's call you a scientist. Suddenly, all the doors just opened up. And
They didn't call you Snowden.
no, this was long before these things. WikiLeaks had happened, but things have changed dramatically. I wouldn't be able to do what I did, I don't think. So anyway, my embed happened to be in the command center. You've seen them in movies, the giant monitors, lots of people, lots of computers. That's real. And they let me have full access to this data. And then when it came time to telling my story, I said, how much of this data can I take with me? And the answer was none. And so I said, okay, well, what was the whole point of this whole exercise? More backdoor guidance. And then finally, it was like, okay, let's give him a sample of it, and let's see what happens. So they made that happen, and I did some very simple statistical analysis on it, and I said, yes, your death set checkpoints story checks out. I took the data before you implemented that new policy, data after, controlled for seasonality. There's a seasonality to death in Afghanistan, and it looked very convincing. I said, there's this one other claim you made about airstrike deaths. That's even more dramatic of a win story for you guys. Why don't you give me a little bit of that data? And that's how I got them. So bit by bit, following their own positive stories, I got them to essentially create a mosaic of their own data until I was able to go to them and say, all that's missing is essentially a webwork of little bits of data that are missing. Why don't you just give me the whole thing? You've already released essentially most of it. This is just embarrassing. And to my surprise, asking politely got me the whole thing. And so I convinced the military to release civilian, until then secret civilian casualty database. And once I had that in hand, I went to the UN, who had its own body count database, secret. They publish periodic reports from it, but the data is kept under lock and key. I said the military gave me their data. So they gave me their data, and then I went to the only other group that I could find that had such data, which was a human rights group. And they had legitimate reason not to share their data because the data comes from a network of essentially civilian spies, do-gooders in villages all over Afghanistan who verify things that happen. And after some anonymizing of locations and aggregating across months, I got that too. So the frustrating thing was when I got home with all this data, I had to get help from people who knew how to do stuff with data to tell my story. And that, eventually it worked, and I worked with a buddy at Google who he's a data artist. There's no other word for him. And we built a beautiful representation that helped me tell that story about the changing nature of death in Afghanistan. It was a data-driven story. So that was the first kind of like wall I hit. I was so proud to get all this data, and it's like I had all this stuff that I couldn't do anything with personally. I sort of had ideas for what to do with it, but I just couldn't do it myself. So then the second project that really just completely frustrated me was the group that I work with at Harvard. They created the Ngram viewer. If you've ever played with a thing at Google where you put in a word or a phrase and it shows you the distribution of that word or phrase in all published books for the past 200 years. You should play with it if you haven't. Look up Google Ngrams. I did a project with the group where I wanted to depict the history of science by showing the changing distribution of the names of famous scientists over time. So, in this century, we've got Stephen Jay Gould and Albert Einstein, but in the previous century, there are names that you have never heard of who were rock stars. And so, there's a really interesting story to tell by showing how the evolution of scientific fame evolves. And again, like, we were able to get all this data, and I was completely relying on this undergrad who, only had so much time for me. And just the fact that it was an undergrad who I was waiting on, like, hand and foot for telling my story, that was like, okay, that's enough. So I have to learn Python. Because that's what they were all, everything I've just described, Python was essentially being used from beginning to end. So I was like, okay, what is this thing? I got to learn how to do Python. So how's the font going?
Can we, sorry to interrupt, can we open a different text editor to view these in? I don't want to
Sure.
frog your machine with that.
Yeah, no. Do you know anything that has pretty colors that I might have?
Yeah.
You might be better off just going with it, and we'll have to make.
Okay.
I wouldn't want to.
Yeah, okay. Don't worry. You're not going to have to follow word for word. I'm going to point out the interesting things anyway. Okay, so I didn't know any code a year ago, and here's the story that got me into this. I was contacted by a Nigerian scientist, a real one, absolutely real. And she had a problem. She felt like she was getting duped by a journal, an open access journal that seemed to be free when she submitted her paper. There was no indication that there was a fee to submit or a fee to be published. So they led her along this long process, mostly consisting of editing her paper to fit their needs. And finally at the end, they hit her up for $150, which doesn't sound like much to you in this country, but is a lot of money for a Nigerian scientist. And not only that, but they wanted her to pay with PayPal. And she doesn't have a credit card. Most African scientists don't. So she was incensed by this, and she told an American colleague whom she had met at a workshop for epidemiology the previous summer. And he got incensed, and the both of them started just like emailing people in the science world saying, we've had enough of this situation where journals are preying upon those who can least afford to be preyed upon. They're hitting developing world scientists up for fees that they're not advertising, and there's a whole litany of other problems. If you've ever heard of predatory publishers, that has come to be known. This is the kind of the name for this whole collective problem. And I was pretty unaware of it. I was vaguely aware that it was a problem, but academic publishing is just not my beat. Even though I'm a correspondent for Science, which is a journal, like I'm a feature writer. Like I write features for Science and features for Wired magazine. So this is kind of an arcane world for me. But I was really moved by this problem of someone trying to get their work published and essentially being preyed upon by this fast-growing industry of fake journals is what they really are. And I looked into the one that she was having problems with, and every detail that I checked didn't check out. They said they were located at this place in California. I looked up the address. It's the intersection of two highways. There's nothing there. They have no phone numbers. They wouldn't respond to email. Just everything about it was fake. So then that led to a natural question, which is, how bad is this problem? I mean, what percentage of journals in the world are doing this? Or can you be more specific? Like, is among exactly this type of journal, which specifically is an open access fee charging journal. So these are journals which, rather than you getting a subscription to, once a paper is published in the journal, anyone in the world can see the papers, which is brilliant. That's the great part of open access. You don't have to be a member of a rich university to read science that usually you've paid for through tax money. However, someone's got to pay the bills, and the way they're doing it, at least this segment that I'm talking about tonight, is you charge the author. Now, that does create some problematic incentives, at least over the short term. No longer does, well, you can imagine. You get very high return on investment. Imagine you just create a fake journal. You just clone a website. In fact, the one that I looked at in the first place, I discovered was a literal ripoff of a published since 1946 journal by Wiley called, anyway, all their journals were ripoffs. They just took text, they basically scraped the websites of these journals, changed enough to look distinct. You know, if the old one had the Journal of Polymer Chemistry, they would add the word American to it. So it was the American Journal of Polymer Chemistry. How would you know? That sounds totally legit. And the website looks totally legit. But what is it besides just a blog with a PayPal account attached? And so anyway, I wanted to get to the bottom of this. And I had essentially 3 tasks. The first is, how do you submit? First of all, how do you figure out how many of these journals are out there? There is no one list. I'll get to that in a sec. Then, once you figure out where they are, how do you submit thousands of unique scientific papers to all of these journals? They have to be different enough. So if you submit the same paper to thousands of journals, it's not going to be long before someone figures it out, and the whole thing goes bust. There's a lot of cross-checking. And also, as soon as one of them gets published, even if by accident, they search for plagiarism using software now. So they're going to find it very quickly. So they have to be sufficiently different. Every paper has to be different so that essentially my ass is covered for getting caught out early in this experiment. But they have to be similar enough that I can, at the end of this whole thing, I can show you 2 lists. These are the guys who accepted a paper that was fake and awful. Trust me, I created it. And these are the guys who passed that test. And for the first time, we would have a roadmap to kind of a consumer's report. Like these are the guys who passed a really simple test to peer review, and these are the guys who didn't. I'll leave it to you to make up your mind what happens next. So that was my goal. But first of all, how do I generate all those papers and make them unique? For those of you who have coding experience, that sounds like an easy pet trick. For those of you who don't have any coding experience, you recognize it for the sorcery that it is. And then at the end, once I have done this whole thing, if I somehow pull it off, how do I tell my story? How do I get all that data, the outcomes, and also I had elaborate ideas for maybe I could figure out where all these guys are in the world, because they all lie about where they are. Maybe I could use IP addresses, I can use whois registration information, I could actually build a map of where everyone is. But how would I get all that data in one place? Ian was making fun of Excel, justifiably. But as you'll see, a CSV file is your friend. If you're not dealing with a huge data set, do the easy thing. Use a data structure that is fail-safe, intuitive, and you know how to plug in and out of with Python, and that's what I did. All right, so I just want to show you the first one. Good. Okay, so this is the first piece of code. This is the first thing I had to solve. Essentially, I built a list of my targets by scraping 2 websites. One that's based in Sweden. It's kind of like a big library of open access journals, and they were just so transparent. It was just like butter. You just download their CSV. Here's our current data. Bam. So no fancy tricks needed. Got it. The second one was a little tricky because it's this guy who keeps track of bad guys. His name is Jeffrey Beal. And he has something called Beal's List, which is essentially kind of a laundry list of publishers that are on a shit list. And it's very controversial because he doesn't really give explicit reasons why anyone ends up on his list. So, and also people have complained, once you're on his list, how do you get off this list? All these publishers are emailing, we've improved. And he's like a Batman figure. Tough justice. But anyway, so I had to figure out how to scrape his website. So this was my first lesson in Python. Sometimes don't use Python. And if I had figured out by then how to scrape a website, I would have just scraped the website. I didn't know that yet. And so the best I could do, if you copy and paste a web page and you're trying to get an actual table out of it, it's a nightmare. It doesn't come out as a table. It comes out worse. So what do? You press Command U and you look at the HTML and you notice, oh, okay, so at least it's in lines in this case. Anyway, in the end, I spent 15 minutes just going through a text document, getting rid of the garbage, and cleaning it up to the point where I could have the contents of his website, that list of publishers. All I needed were the URLs. And that sounds really dumb, and it is dumb now that I know how to scrape a website, but I was on a deadline. Like, I needed to get this thing going as soon as possible because I knew when it would be published. We actually had a special issue in Science devoted to science communication in October. That was my destination. I had 1 year to do this. I got to get started. So sometimes I quickly learned, don't try and learn the coding trick. Just do whatever you have to do. And if you keep encountering the same problem, OK, it's time to invest in learning the coding trick. All right, so this was eventually the output. Once I had that list, the next thing I had to do was generate thousands of papers. At the time, it turned out in the end, I only needed to generate 600-odd papers. But that was after I cleaned up the data and I realized that the target list was much smaller than I realized. But in the beginning, my list was over 2,000. So I was like, OK, I got to generate 2,000 papers. So what I did was I essentially created a template. I'll show you what it looks like. Anyone familiar with the game of Mad Libs? So this was my Mad Lib. Everywhere where you see weird crap in all caps, that's just a little marker. And guess what? All you have to do is go in and replace, let's say, title marker, for example. All I want my program to do is look at the template, get a copy of the template. When you encounter something called title marker, go into a little spreadsheet that I created, a little CSV. Keep it going down. For every row in the CSV, I'm going to make a new paper. So for each row of the CSV, I said, grab the title. And I had already generated a unique title for thousands of papers. Stick in the title. It's just like in Microsoft Word when you do a replace. But I have several things to replace, and I want the contents of what gets replaced to be different for each one, because I'm using a database. So manually, impossible. With Python, took me 10 minutes to generate, actually, I mean, it takes 30 seconds to generate 100 papers, which was my first test. I was like, oh my God, in 10 seconds, I just made 100 unique papers. And so that's the beautiful thing about computer coding in general. Once you solve something once, doing it 1,000,000 times, it's the same thing. So here was my breakthrough. This is like I was proud of myself for the first time. I figured out that if you want to make a couple thousand Microsoft Word documents, that end in .doc, and that's what all these publishers wanted. They were very explicit. It's got to be a .doc, not a .docx, not an RTF, not a text file. It's got to be a doc. There is no Python interface for doc. There is kind of one, and I just could not get it to work. And in fact, it had been abandoned. There's now a docx library that lets you do fancy things with docx. And there was a beautiful PyRTF library that would let you deal with RTF documents. And there was just nothing in the middle. And I thought the whole project was dead for the dumbest reason. I just can't make doc files. And then my breakthrough, and this is like my second Python lesson, is that sometimes doing what seems to be wrong is like the solution. I just changed .rtf in an RTF document to .doc. And it works. Microsoft Word will happily open something that is actually an RTF document if you just change the file extension. And I learned that just by frustratingly fiddling around trying to get anything to open anything. And there it was. And I'd already figured out how to do this with PyRTF. So here I am importing PyRTF somewhere. Actually, maybe I haven't even done that in this. Oh yeah. So, and also you'll notice this is really crufty, and I wanted to show you warts and all, what this actually looked like. Syspath append pith. That's because I couldn't figure out how to get this thing to import into my standard folders. I didn't know env. I didn't know virtual env. I couldn't do it. So, but exactly, whatever, solve the problem. And I was like, okay, if I say syspath append, will it work? It does. Fine. Okay, and now I have a huge library sitting locally next to this code in my folder. Fine, it works. Here's what the output looks like. Here's a scientific paper. How do I full screen this thing? I don't know if that's possible. Complete, by the way, with molecules. that molecule, I just scraped thousands of molecules from PubMed, PubChem, Open PubChem, something. There's a totally open database of molecules, and I just constrained them to molecules. I found that the sweet spot for molecular weight of stuff that looks like this, which is like, well, that looks legit, is like, you know, whatever, 200 to 300 or something like that. I just found the sweet spot, and I just generated like thousands of chemicals. I generated data. And this, by the way, I wish I could get rid of all of these menus up at top of Microsoft Word. I hate Word. I don't use it. Anyway, I used R for this. If any of you do deal with data at all, like in Excel, in a very simple way, go to R. Learn how to use R. It just is so, so beautiful. And it let me programmatically generate thousands of fake data plots, for example, if I wanted to. Anyway, the key thing to this, this is like the first thing that any peer reviewer who saw this paper should just like be really sick about, is the dose-dependent effect of this random chemical on the growth of these random cells. Tell me if you see a growth-dependent effect. This is 5 orders of magnitude of concentration. So growth-dependent, so dose-dependent. Anyway.
I like that you made sure to have error bars. It's definitely a pro tip.
Makes it legit. And here, by the way, is just a little Easter egg that no one knows about. All the people thanked in here are anagrams of the people who helped me out on the project. Sneak. All right, so I also generated a fancier, revised version of the paper. It has a different layout. It's kind of like, I threw in a few photos of lichens. Supposedly this is a paper about the extraction of a chemical from lichens and that it cures cancer. And there's the thallus of a lichen. Anyway, there's absolutely nothing different about the paper. But sometimes when I would submit the paper to a journal, there would be kind of an editing process. And it was like literally, most of the time it's a joke. It's either like, we want to see a longer paper, or please change the format of the references. Very rarely does it have anything to say about the scientific content. But I had this on hand. For every paper, I generated a revised version that looked fancier, looked like work had happened, so that I could efficiently submit. Because keep in mind, as I scaled this up, I had hundreds of papers in the editing process at any given time. So, and that generated a problem. That's the third lesson that I learned about Python, is that most of the problems you have to solve, you made yourself. And you'll see why later. OK, so then this is just a little trick that I used to try. I cut every corner I could. This whole thing was not automated. So I found that roughly half of journals let you submit your paper by email. And the other half, it's basically a giant CAPTCHA. You have to like create a username, actually solve a CAPTCHA, give some personal data, upload your paper, and then keep track of some code. So that's where the bulk of the actual hands-on manual time is. But for what it did mean is that for half of my targets, I could just like send them all at once, and that's what I did. Until Yahoo detected me as a spammer and they deleted the account. And then I had to, that actually happened. That set me back a couple weeks. But then DreamHost created a fake email domain, afromail.com. I even created a WHOIS registration that made it look like a legitimate email company based in Botswana. And this is how simple the code looks for automated email. If you want to be a spammer, all you got to do, import a bunch of crap, which, by the way, must acknowledge, the vast majority of this is Stack Overflow. I mean, I didn't figure out how to do this. I just figured out how other people solve similar problems, cannibalize their code, and once you get one, you successfully send one spam email to yourself, you're in business, right? So, and look how short it is. Ta-da! This is the end. This is like the longest piece of code I wrote. I did write about 60 pieces of such code for different problems. But you know, my code never gets that long. And here, by the way, is the email itself. Dear editors, please find attached our submission to the placeholder, blah, blah, placeholder. And what gets plugged in there is essentially the name of the journal that I'm submitting to and the name of the authors who are submitting it. And you attach the paper that, you know, the CSV file says is the right one. Bam. Hit send to 100 journals. That was great. OK, here's the problem. Now, I said you create a lot of your own problems. I used one email address. I actually used several email addresses, like half a dozen, over the course of the sting, which took about a year. But the bulk of it was done with one email address. So at the end of this, okay, I did indeed finally submit 304, actually more, 350-ish papers, and got acceptances or rejections from 258 of them or something like that. And so my data looks like what? I've got a spreadsheet of a bunch of like metadata about each paper. I've got a big collection of papers, fake papers that I submitted, and variations on them through the editing process for each one. And then the real gold, like the most important part of this data, are emails. And this plunged me into the world of Unix. So the email bot that I was using essentially was creating Unix email. And it turns out that all email ultimately is Unix. I mean, Mac has, if you're using Mac these days and using the Mac Mail application, it's trying to XMLify it a little bit, but it's really just Unix Mail dressed up. It's really still Unix. So the problem is, how do I figure out which of the 3,200 emails goes with which of the 300 papers? So by the end of it, it worked. And I was like, you know, I've got these guys. Now it's time to tell my story. And I have to show the world the evidence. I'm going to publish all these emails that proves that journal A accepted the paper, journal B rejected the paper. I want to see, you know, for every journal, I want to see the whole list of emails. But they're not sorted. So it's just a huge, you know, collection. And if I go through it manually, it's going to be a nightmare. So as you can imagine, there's going to be a really ugly list of logical patterns. And here they are. Basically, you know, you go through each email, and if, you know, here's the order of things. If the person who sent the email or the person who received the email has the same domain as the website of the journal, stick it in, look up in the CSV file which ID that is, and stick it in a folder on my computer there. Go through. That already grabbed like half of them. Brilliant. OK, now it's turned from a 3,000 email problem into a 1,500 email problem. Next, search through the text of the email. If the name of the journal is quoted anywhere in there, stick it in to that folder. That took care of about 75% of the remainder. Then, like, the last trick was if the name of my paper or the metabolite, so the unique chemical that I used for every fake paper, appears anywhere, stick it in there. And all that was left was like a few hundred emails. And that's not so bad. That was like a day's work. So I took something that was just like hopeless, and with a little loop, a little bit of logic, I fixed the problem that I created for myself. So what should I have done? I should have, of course, created a unique email. By then, I had already created a fake email server. It would have been trivial-ish to create a unique email for every submission so that it sorts itself. So you live and learn. Sometimes, you know, you create your own hard problems. This was actually one of the hardest problems I had to solve, and I completely created it myself. Finally, how do you take all that data and really tell a story? This was kind of the neatest part, I thought, of the story. Like, so you know, I figured out who the cheats are. You know, I know who accepted and rejected this paper that was so bad that if you like had an undergraduate degree in chemistry, you should have rejected this paper. I know who the bad guys are. But wouldn't it be cool to show where they are? Show, you know, actually where their operations are? Because whenever they accepted the paper, they sent me an invoice saying pay up, transfer money to this place. Occasionally they would ask for a PayPal account, and I said, oh, I don't have a credit card, but I can do a bank transfer. And they would, so all of these fraudsters sent me extremely intimate details about their financial operation. If many of them don't even have bank accounts, they're accepting Western Union cash, a huge portion. And they would give me their name and address. How else do you get paid? Meet me here. This is who I am. So, okay, I've got all that data. That's great. Also, by the way, all this back and forth email with the editors, you open up the raw headers of any email, and this is the weird reality of the internet. There's a paper trail showing you where the hell that thing binged around. And you can reconstruct, with some exceptions, where people are. The exceptions, annoyingly, are anyone using Gmail. Google hides, I don't know how or why they do it, but the paper trail goes dead in California. So no matter where you are, if you use Gmail, you can't reconstruct the location. So in those cases, those subset of editors who are using Gmail or a Google-based email system, I would send them an invitation to a conference saying we were interested in having you as a keynote speaker. And we would like you, we want to know where our candidate speakers are. We're trying to figure out where to base them. Anyway, I made up a story, and all of them told me where they are. So then I had the location of everyone. And then the tricky thing was converting those IP addresses into locations. So an IP address, at least the old school kind, is 4 numbers separated by decimals. And that turns out to be, for whatever reason, base, what was it, 256 for obscure computer reasons. So what I was able to download on the, so if you have an IP address, you can go to websites that are free, plug it in, and it'll actually bring up a Google map of where that location is. But if you want to do it programmatically, if you have hundreds and hundreds of IP addresses, and I actually had well over 1,000 by the end that I had to find the locations of. The best that I could figure out how to do, maybe you guys know better, I couldn't find an API. I was willing to learn how to deal with APIs if someone would give me an interface. Someone actually made available a big CSV file as a lookup table. So the way it works is you've got IP addresses that are actually I just don't know why, but in ranges of decimal. So you take an IP address, which is base 256, and you convert it into a decimal number, which is a huge, gazillion. It's a number, like 4,393,000. That's the IP address. And the lookup table says if it's between this huge number and this huge number, you are in, Kosovo. And so it's not, once you figure that out, once you figure out the logic of it, it was not that hard. But I was just kind of baffled by this. But then, it was so satisfying to figure out how to take a whole bunch of IP addresses, convert them into decimal numbers, check if they're within a range, and output not only the name of the country, but the ISO 3, which is the 3-letter code for countries, which is what I needed in the end. Because the goal was to make something like this. So this is what I wanted my story to look like. A map of the world with dots all over it that show you where these guys are based, okay? Each of these rings that you're seeing is the location of, and this is not, this is only within country. It's a random cluster within each country. The Midwest is not the publishing capital of the US. Each of these circles is a single publishing house. Any one of these may publish between a couple and hundreds of journals. So you're looking at the global population of open access publishers who publish, who charge fees. So the actual full open access world is much bigger, actually, because a lot of subscription journals are going open access. So there's a lot of change afoot. But anyway, these are the guys I'm interested in. Green means you rejected my paper. Red means you accepted it. So then, let me make this a little bit smaller so I can get down here. This is where your bank accounts are. I'll make this smaller so that kind of crappy on this screen. Maybe I'll just make it bigger. I'll just show you little windows on it. So this is what it looks like. And just you can see the URL if you want to play along. This is where the banks are. So for example, we discovered that Turkey is one of the fraudulent banking capitals of the world. And India, this is where telling your story with a map is not just telling other people what you've discovered, it's discovering for yourself what your story is. I just did not realize that India is the academic fraud capital of the world, at least in the publishing world, as of this year. And finally, tracking the IP addresses shows where these people actually are. Now, where you see editor, often that's actually the publisher as well, especially when it's red. Where you see red lines, here's my favorite. This guy who hangs out in the Seychelles. There's a guy. These guys in the Caribbean I love. They totally know how to live. And Canada, slightly better than the US, but only slightly. And really, essentially, the only good guys are really, to a first approximation, are this trunk of connections between Europe and the US. And sadly, and really I didn't want this to be the story, the developing world, not only is the developing world where people are disproportionately being preyed upon by these publishers who are not doing peer review, being deceptive about charges and all the rest, often they are themselves based in the developing world. They're really preying upon each other, largely. However, very disturbingly, some of the biggest publishing houses that are red on this map, the profits are ultimately going to the West. So I found that Elsevier, Wolters Kluwer, and Sage, who are three of the biggest publishers and most prestigious and old publishers in the world, have gone deep and fast into this new burgeoning open access industry by acquiring huge collections of open access fee charging journals, especially in India, and working out deals where they host it. It looks like an Elsevier journal. It looks like a Wolters Kluwer journal. They brand it. They make sure that all the papers that are submitted to it are getting cataloged into the databases that we all use to make sense of scientific information. And in return, they get this huge fee. And what do the publishers get? I don't know, supposedly like a shot at the big time. I'm not sure what the business model is, but I guess the idea is, we're running a crappy journal. Let's get a leg up. Let's let this big company with all this experience help us out. And what's really going on is it's just a pyramid scheme. And the real victims are all of the authors who are getting duped. They think that they're taking part in the scientific process, paying money to do so. No peer review is happening. They pay, it gets published, the money's ultimately going to the West, and we, the people of the world, get to go online, and as happened in 6 cases, even though whenever my paper got accepted, I sent a standard email, automated, saying, right after the acceptance letter, I can't believe we didn't see this sooner. We've discovered a fatal flaw in our own paper. We have to withdraw our paper. We're going to repeat the experiments. We'll get back to you, but we have to withdraw. And usually, I'm the customer. They were like, "Cool, get back to us. You're our money." And so, I haven't been sued yet. I'm waiting. I supposedly owe a lot of money to a lot of companies, but I hope that they're taking the tack that it would only make it worse by trying to sue me, which would be, by contract, thank God, suing science. So yeah, if you want to sue, science, a nonprofit scientific journal, the most prestigious along with Nature in the world, that'll help your reputation. Anyway, so this map, China, by the way, not so bad. When I went into this, everyone was like, "Oh, it's going to be China. China's the bad guy." It's not really, not really. It actually has a similar distribution of good and bad as America. I mean, 50-50-ish. I mean, you have to go to a place like India, 90% fraudulent, or Nigeria, 100% fraudulent, to really, like, you know, see an industry that is enjoying its spring.
In the South Latin America, or
There's very little down there. We had one acceptance from Brazil. The Brazilians are furious. These guys right here, the Ribeiro Preto Foundation for Scientific Research, FunPec. So that is Brazil's, like, they really had pinned their hopes to this publisher to like make a name for South American science. And sorry, like, maybe you are doing great things, but you accepted trash and asked me to pay for it. And it's just amazing. They've recruited, I can only guess, they've recruited people to go to comments, you know, on blogs and make it seem as if they didn't accept the paper. You know, they've made the claim that that wasn't a real acceptance. It was like, you know, provisionary acceptance. It's a standard procedure. It wasn't going to be accepted. If you look at the emails, it's just not convincing. Here, I'll show you. Here are the emails, and okay, they're asking for $820. That's the invoice. Yeah, let's see if we can find the acceptance email. This is me complaining that they were taking too long. Okay. Yeah, I can't remember where the actual. Oh, I know. It's like up here somewhere. Dun, dun, dun. We acknowledge the receipt of your paper. Here it is. Here's the code. Da 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 da. Here's me. Oh, that's the same email. Probably should just memorize where the acceptance is so I can do this in a snappier fashion. Then they took a while. I was like, is it accepted? We're asking for payment of publication fee at this time. There you go. And you know, and you have like the official invoice of how to pay. Notice here, by the way, is my final Python lesson. So we went all over this whole thing before we published it with a lawyer. And the lawyer was like, you know, this sounds fine, but you have redacted all the bank account numbers, right? So I had 3,200 emails with some unknown distribution of bank account numbers. And by the way, I checked, bank account numbers come in a variety of layout. And many of them were in PDF, some of which were readable, some of which weren't. And by the way, like, even if you figure out some tricks and you take care of a bunch of them, you're gonna have to human check all of them anyway. Like, this is just, we could really get sued. So if you're gonna have to read them anyway, what's the most efficient way I can do this? Sometimes the solution is so beautifully simple. I gave the intern at Science a bottle of really nice scotch. And she did it, all. And we figured out a tool that made it a little bit faster. Adobe Acrobat Pro has a redaction tool. Turns out that if you just put a black swatch over a PDF, it's not redacted. If you copy and paste the contents of a supposedly redacted document into a text file, it's still there. So the only way you can do it is to actually, like, obliterate a quadrant, you know, like this. And they have a tool for that. And of course, it has too many steps. It's like, highlight, save, save as, yes, save as, yeah. So that times hundreds, and I got someone else to do that. And then also, the other thing is like this map, totally not me. The data, like, to tell this story, I had to get all this data. But like, your skills only go so far. So this is D3 in action. D3 married to someone's awesome globe, like open access globe. I guess it's this person here, Derek Watkins. And this is how really cool things get made. You go to your friend, you convince him that, like, I could probably get you $1,000 for this. And you just say, it's a really cool story. And your name, by the way, David Quinn, Daniel Wiseman, brilliant, brilliant visualizers of geodata. You will be, immortalized for, no doubt, disgustingly controversial story in science forever. And, and they agreed. And then began an incredibly intense 11th hour visualization project right before publication to get this thing up and running. And they used something called D3, which I had never heard of, but apparently does magic stuff. So, and it's just beautiful. You can click on links. It tells you where these guys are. The emails are all right there. Oh, and by the way, I found when you click on any of these emails and it actually gives you an email, what's doing that? It is a little Python library. This is the other super thing about Python, is that for every problem, just about, someone has invented a library that will more or less do what you need. So I had to, and this was like all on the weekend before publication, like I realized that all my emails were in Unix. Like, how was I going to share that with the world? I had been visualizing all this with like email visualizers, like Mail and Thunderbird. And I was like, oh, God, we can't ask the world to just download an entire mailbox and then browse at will. So problem solved in like one morning. PyPDF, I think it's called. It allowed me to convert all these emails into PDF documents. Bam, done. Thank goodness. So I'm sure I've missed some key, you probably, that's one thing I wanted, for all the actual beginners out there, here is a website that I made for you. A little part of my homepage. Write it down if you want. My email address, by the way, is just john@johnbohannon.org. Would love to hear from you. I did this for a class, a little workshop at Harvard called Python for Journalists. And what I wanted to do was take all those chunks of code that I used to solve my problems and boil them down into the essence of what they were. So if you download the puzzles here, it just walks you through essentially the Python for Py for journalists. Where is it? There it is. You can see my Dropbox underwear. It starts off as simple as hello world. And under every puzzle, there's a little make it do something else, something clever. Here's one that teaches you how to do a loop. And if you run it 1,000 times, Britney Spears. And, and this looks trivial to you coder people, but still, sorcery. So, and there's some fun data stuff. So I downloaded the top 50 baby names from every English-speaking country, and you get to find out essentially weird things about the English-speaking world. For example, the #1 unique name in Australia is, it's stereotypical.
Sheila.
Ooh, should have been Sheila. No, it's Matilda. Anyway, you need Python to answer those kind of cute questions that are at the bottom here, these little to-dos. I made something that teaches you how to do dictionaries. I made something that teaches you basically how to make a function. Totally straightforward. Anyone can follow this. I basically made the kind of things that I wish I had at the earliest stages when I was like, okay, now I have to make a what? A function? But it gets a little more interesting. For example, I don't know if I'm online and it'll work, but I made the most basic web scraper possible. Now, to do web scraping, you need to download something like LXML. There's just no other way around it. But actually, Python has some built-in basic scraping stuff that really takes you far if you don't need anything really fancy. And so I made a little program that just gives you the absolute basics. And it has a few little puzzles that involve colleges. That's fun. I also made a more advanced scraper that scrapes crime reports from the Cambridge police. It turns out they have a really nice, simple, modular date-based URL system for crime reports. And so it outputs Here's the latest crime reports. And it's, nice HTML. Some of them don't work.
We should have time for questions.
Yeah, okay. In Central Square, there was an incident.
After being observed imbibing what appeared to be an alcoholic beverage.
Yeah.
Later at Mead Hall, we're going to have what appears to be an alcoholic beverage.
Anyway, feel free to download these puzzles, and I would love feedback on how to improve them. My ultimate goal is to do better than pythonchallenge.com. Has anyone ever played pythonchallenge.com? I'm surprised it's not more famous because it's such a great idea. So when I first started off in this, I love puzzles, and I was trying to learn Python, and I discovered there's Learn Python by Puzzles. It's pythonchallenge.com, and it's really, really clever. But first of all, it goes way too deep too fast. It's really for coders who want to learn Python. And secondly, it's like all puns, and I hate puns. So I want to actually make with your help at some point, maybe Project Night, I'd love to make like a journey of puzzles that are really fun and actually make you learn Python along the way. So you have any questions?
I just want to say you tell a great story.
Yeah. Data.
No, you tell a great story.
Oh, I tell a good data story?
So I'm wondering, it would have been really, I'm a scientist.
Oh, by the way, the answer was 60%.
Yeah.
I don't know why I never said that. 60% bad guys.
Right. So
Right.
I'm a scientist, and I have to publish, and we've known for a long time that a lot of these publishers were or suspected it.
Yeah.
And I'm glad that you did this so that we could actually put a number on it.
Yeah.
And point fingers and know. But one thing that would have been really interesting is if you had also submitted a lot of dummy papers to some non-open access journals.
Yeah.
Is there any reason that you didn't do that? Or?
Yeah, absolutely. There are several. The first is that it can't be done with this experiment, at least as designed. The turnaround time for a print journal is months, often more than a year. Yeah. And I need to do hundreds at the same time. And even by July, 6 months into this thing, I was getting emails from editors saying, hey, we checked your paper and it looks like you're plagiarizing this guy. Because already, they were starting to publish the damn paper, even though I was like, don't publish the paper. It's bad. I withdraw it. So essentially, the clock was ticking on this whole project. Secondly, I actually was kind of conferring with open access advocates the whole time. Ginsburg, Stuart Schieber at Harvard. They cared deeply about open access. And the advice I got was, just keep it focused. If you try and make this a comprehensive thing, you're inviting comparison. There's no way you're going to get a comparable sample of print journals. I had some discussion what if we weight it by impact factor? Wait, you want to use impact factor? No one likes impact factor. That's going to be controversial. Well, okay, what if we take a random sample? Well, random sample, that's not going to be meaningful because the distribution of journals is really messed up. And how do you divide it by subject? I was hand choosing one journal for every publisher to make sure that it would be more or less thematic with a cancer chemistry paper. So in the end, I took their advice, and practicality basically forced me anyway to keep it focused on open access, fee-charging journals.
I wanted to ask you about the text substitution you did. That simple substitution was enough to camouflage your paper from the plagiarism?
Yeah, so the authors were all different. The institutions were all different. The title was different because it was a Mad Lib on the form of molecule X inhibits, from lichen species Y inhibits cancer cells Z. So different title, different authors, and enough of a difference in the text that it was at least camouflaged. But it wasn't enough. Once a few of these were actually published, they used plagiarism software to actually automatically detect whether you've multiply submitted. So the gig was up after about 6 months.
Text in the paper, the body of the paper might be a giveaway.
Yeah, there were huge chunks. The largest was half a paragraph of unique text, and some picked up on it.
How did you make up the different titles? So how did you make it different for 1,000 pages?
So I just made a huge list of molecules, which I downloaded from PubMed or PubChem. I made a huge list of lichen species, which I basically poached from a database that someone had created for lichen taxonomy. And I actually handmade cancer cell lines by permuting several elements of what makes a cell line. So murine, sarcoma of blah blah tissue, blah blah transformed. Basically 4 to the 6th, you've got plenty to work with there. Whatever.
So why stop now? I mean, why not just keep doing this and just have like a list of...
So one idea I've heard floated is that we should create an IRS for science that randomly and infrequently audits journals with a high price for failure. The problem is, who's going to be the IRS?
It's like you don't have to, like, they don't have to pay anything as long as people know that it's junk. Like, that's the reputation is the killer.
Yeah, I mean, the problem is that reputation is not the only coin of the kingdom. For a lot of these journals, it's like get as many papers into the door. And it's not just open access. Elsevier has this problem because they bundle huge numbers of crap journals and they have to feed the beast. So I've heard complaints on both sides. There's no clear solution. The best I've heard is that we should have a list of good guys who are regularly vetted by a professional group. And such group exists. It's called OASPA, the Open Access Scholarly Publishers Association. And right now it's a very small list. And so maybe it just needs to grow.
Why don't you let 60 minutes just blow this story over?
I don't trust 60 Minutes. Well, I mean, I published it in Science. I think the audience that should care about this now knows about it.
One more.
So what universities or institutions do you use? I mean, I would guess that there's people say, oh, this is from people from Harvard. This paper,
Yeah, I made completely fake. You're talking about the author affiliations in the paper? Yeah. I'll show you an example. They're all fake. Here's just one example. So the thing that got all of this started, so there is no Bokeh African Research Foundation in Brazzaville. And all of the affiliations are fake in all the papers. When I started, before I even thought of scaling it up, I wanted to replicate the experience of that Nigerian scientist who contacted me. She made these claims about this publisher, and I was like, all right, well, I'll see for myself. I'm going to submit a paper. And I made fake African authors and made it from fake institutions because they're not Googleable, and that's OK. So if an editor sort of Googled the authors and didn't find them, it's not that suspicious. Africa doesn't have a big Google footprint. So once I realized that if I'm going to scale this up and they have to be all unique, I should probably stick with African authors. It goes under the radar. It wouldn't be suspicious that they are non-existent. And indeed, in only one case out of hundreds of submissions did an editor ever say, I couldn't find you on Google. And I told that editor, our website is down. and then they accepted the paper. So I feel like this was the right choice. That was exactly the right diagnostic tool.
All right, thank you, John.
Thank you.